Hi guys, welcome to Essence of Medicine. Okay, let's start over. Hi guys, welcome to Essence of Science. Today we're going to be talking about Are We Dead? My name is Amanda Armagost.
Dominic Moore.
And I'm Dr. Abbasi for Essence, but I think that is the rather essence of life and philosophy than science, because by the way, what we are going to talk about is not for faint of hearts. We are going to describe many philosophical concepts. All of them are PhD level, philosophy level, and sometimes some of that will be hard to follow if you don't pay attention. You need to have certain vocabulary to understand these concepts. So,
and I will be here to make sure that you can understand them, because obviously I didn't study philosophy or have a PhD in anything. So if the word is too large or confusing, I will stop everyone and get a good answer.
That's a perfect way to go about that. Now, but I would definitely recommend to change it from Essence of Science, because none of the things we are going to talk about is actually science. It's philosophy. So Essence of Life is a more appropriate category for this podcast. But I think that was your idea, Dominic. So tell me, how did we come to talk about Are We Dead?
Okay.
What do you mean?
So my friends and I, sometimes on the weekends when we talk, we go pretty off the deep end onto different topics. And one of them is very interested in physics. And he kind of broached the topic. He came to us and said, guys, are we actually dead? And I was like, Stephen, can you calm down for a moment? I'm pretty sure I just had some salmon, so I think I'm alive. I'm having a great night. And basically, he broke it down with the first thing that he wanted to describe was time. And the idea that the way we perceive time is very much linear. I cannot perceive time yesterday. I perceive today and tomorrow and the future and whatnot. And essentially, he used an analogy of a drop of, like if you drop tea in a glass of water, you watch as it disperses. And then eventually it just goes all throughout there.
What do we call that?
Diffusion.
Entropy.
Oh, okay. Yes. And essentially the idea is that you don't go back from that, from our perspective. But each one of those molecules that were tea and now in the water, they occupy a space. And the idea there is that in theory, they could occupy any number of spaces. They just happen to be in those ones. And so the idea from that becomes giving how much time? We don't know, but an infinite amount of time, eventually you would be able to see it in a different shape. And that's sort of where we started from there.
If I may compare your analogy, which is a very good one, as a matter of fact, in philosophy and physics, a drop of milk in the coffee is used. Mm-hmm. So you have coffee, you put a drop of or some milk in it. You always see that the milk disperses, but you never see the milk coming back together. But what you're describing is that based on our understanding of physics and philosophy, if you give it enough time, that enough time can be billions of years, eventually that those molecules of milk come back together and become a drop eventually. And that is actually, for people who are interested, Misha and I, we did a podcast about Poincaré theorem. You can go back and read about that. This is a true philosophical concept, and I will come back to you, and I want to have your take on that. But let's start with something simpler, like a deck of cards, right? Yeah. You go buy a deck of cards, it's from factory, it's sorted, oriented. Like first you have one versus another, 1 to king, whatever they call it, and so on. It's totally organized, right? Now, you take it, you throw it in the air, they come back down, and then you just put them back together. What is the chance that they come back together in the same order you throw them up? What is the chance of that?
Wouldn't it have to be like 52 times 52?
It is 52 factorial. Meaning that 1 times, 2 times, 3 times, 4 times, 5 times, and so on. If you calculate that, that's the astronomical number. Now, why don't they always come back the same way? Because there are so many different ways of these cards to be shuffled. As a matter of fact, I think you told me that, or somebody told me that, I think maybe even you, that if you shuffle a deck of cards, there is a chance you shuffle that for the first time in the history of human being and universe, that you shuffle that card in that order for the first time in the human history, because the number of the ways it can be in a different way is so much more than the number of that it's really sorted, the way it comes from the factory. And that is called entropy, meaning that the level of disorder in any system, in any closed system. So imagine the whole air, oxygen in this room is dispersed randomly. That's why we can breathe. But there is definitely a possibility, statistical possibility, that all the oxygen is that corner and all the nitrogen in this corner, and we all suffocate. But we never suffocate, because that chance that truly one day all the oxygen gathers in one corner is so astronomical. We can calculate that. And it is possible. There is nothing says it's not possible. It's just so unlikely. And that is what the concept of the time means, meaning that the only reason we perceive the time as like, the egg breaks but never come back together, deck of cards become less sorted, then it doesn't automatically become sorted, or airplane explodes but the pieces don't come back together, become an airplane, is that there are so many more different ways of that to be in disorder and in order. And this progression of from order to disorder is actually concept of time that we consider time. Okay, now in physics, nothing says that things cannot be reversed. As a matter of fact, every law of the universe is reversible, including milk gathering itself from the coffee, become a drop. It is all absolutely possible. And that's not a philosophical concept. It's just the basic of life and physics as it exists. Now, based on that, time is an illusion that we perceive. And there are some theories that time practically is, that's why we call it time, space-time continuum, meaning we know that there are 3 dimensions of space, which we call as a general space, and there is 1 dimension of time, and you can move in one or another or any combination of that. Like when I'm sitting right here, just let's say, imagine I'm not moving at all. In reality, I'm moving. Earth is moving, the planet is moving, our universe is moving. But let's say I'm sitting here and not moving at all. All my motion will be in time. But if I start moving faster and faster, that is what the relativity theory is. If I move faster and faster, most of my motion is transferred to space and less to time. That's why time slows down. As a matter of fact, let me tell you something. It's a concept that maybe actually Charlie should cut this part out and to put it as a small short. Did you see sun today, Dominic?
Yes.
You felt the warmth of the sun on your skin? How long did it take for that sun photon, for that energy of the sun, come from sun to you?
How many light years is that?
No, actually, it's a minute. Sun is very close to us. It's 8 minutes and 41 seconds. That is how long it takes that light go from sun, go through the space, come to the earth. But when do you think that photon, when do you think that photon was produced?
How fast is light? Speed of light.
No, but it takes 8 minutes to come.
Dinosaurs were around.
Actually, yeah.
Before?
Well, 300,000 years. In the core of the sun, where the pressure and the temperature is high enough, few hydrogen atom came together, become helium. The rest, EMC square and century, became energy. That photon was produced about 300,000 years ago. That photon, though, in that dense core of the sun, had to zigzag, get absorbed, get emitted again, get absorbed, get emitted again. And it took that photon 300,000 years from the core of the sun to come to the surface of the sun. Then it takes 8 minutes and 41 seconds to come to the Earth. That 300,000 years is for us human.
Mhm.
How long do you think it passed for that photon? How did that photon, if that photon had a consciousness, how long did it take that photon? How did that photon perceive that time, all the time? Instantaneously.
Yeah.
Because photon is at the speed of light,
Mhm.
time doesn't exist. For the photon, everything happens at the same time.
Mhm.
Time doesn't exist. The moment it was created, in the same moment, it got absorbed billions and trillions of times by other atoms and got reabsorbed. And in the same moment, hit your skin and gave you warmth.
That's cool.
But because time doesn't exist. Now, if we all come back now, are we dead? Well, we don't perceive ourselves as dead, but if you take the concept of time away, we are all dead and we are all alive at the same time.
Mhm. Our birth and our death are in the same sort of moment, because I mean, they're just two ends of this little spectrum here.
Yeah. But there is actually the name for that in physics, you know. Have you heard of Schrödinger cat?
Oh, yes.
Yeah.
Yes.
What is that? Amanda, what do
I
you
have
know?
no idea.
Okay.
I'm just laughing because you looked so happy to say it.
I don't think you're gonna like this one, Amanda.
Yeah.
Okay, let's first of all,
is this something about like putting a cat in a black hole and then I get stretched out?
the black hole. No.
No, not that bad.
No, not that bad. Well, I did no. It is about the concept that duality of particle, meaning a particle is a wave until we look at it. When we look at it, it becomes a particle in a specific location.
Mhm.
And the Schrödinger cat, and that is the Heisenberg uncertainty theory.
Mhm.
But it works. That is why everything works. That this podcast, this microphone, this cell phone, all of that works because this is science. Now, where it becomes philosophy and not science is that what this elemental property of duality of the particle does in a macroscopic world. Like, you know, imagine you connect a particle, you put it in a box that can. It is literally either a particle or not a particle. It can decay or it cannot decay. But when it decays, it triggers a series of events that open up a bottle of poison. And in the box is a cat. And then, so the philosophy and the physics says the particle is decayed and not decayed at the same time. Mm-hmm. That means that series of events that open up the vial or a bottle of poison is open and is not open at the same time. That means the cat is alive and dead at the same time until we look in. Yeah. Once we open the box, then all these possibilities collapse to one. Mm-hmm. Then, and if you don't observe it, it can be everything. So meaning that you are actually right. You are observing yourself in that moment. You're alive, but you get your observation away, then you can be dead or alive, and universe doesn't care.
So let me actually to kind of dial it back to the card analogy from earlier with the deck, where you throw it up and you bring it down until you flip over that first card. It could be any of them. There it is any possibility. But the second you flip it over and it's the King of Hearts or whatever it is now the King of Hearts. But before then, it could have been the Ace of Spades.
Yeah, so. It could be anything. Yeah, that is actually a very good analogy about that. Now, the idea of things that we perceive to be real, it is, in a way, scaringly limited. Mm-hmm. Now, like, touch my finger. Do you think you touched me? What do you think?
I think
You
we got
felt it, right?
Yeah, yes. I felt a
But
force.
What if I would tell you when our molecule and atom got close together, the electron of the outer surface of my finger repelled the electron of outer surface of your finger, and that force is what we felt, and we never ever touched. In truth, you never ever touched. The reason you are not sinking in the floor is because the earth, the outer layer electron push against the outer layer electrons of your shoe, and you're hovering over that. This is the actual reality.
Yeah.
Okay, there is a moment you can overcome that, like in a neutron star and so on.
Yes, yes.
Everything, the electron, there's a name for that, electron degeneracy force, like meaning that you overcome that, the electron get absorbed in the proton, become neutral, the whole star is a neutron. So that empty space in the atom doesn't exist anymore. So that's why a teaspoon of a neutron star is like a Mount Everest, mass of Mount Everest. Literally, that's what it is. Imagine if you're made of atom, right? The atom are made of a nucleus and a cloud of electron possibilities. That the size, if you want to take a size, imagine a football stadium, you put a baseball in the middle of football stadium, and that's the nucleus, that's the whole mass of the atom. The whole stadium is the electrons. So that's how little it is the actual mass of the you know, literally, if you would take that whole space away from, literally, if you would take the entire that space away from sun, empty space, you would have a neutron star size of Manhattan. That is how ridiculously small it is. You would be, if you would take all of that away from you, you would be a size of a, less than the size of a virus.
Wow.
But you would be so dense, you would sink to the center of the earth. So you see that there, many things that we perceive as real, like touch, like many of this concept really collapse when you physically look at that, and time is the most important of it. Now, Amanda, how do you know what time it is?
Like looking at the sun, looking at the clock.
What about if there was no sun, no clocks? How would you perceive?
Go off of perception. I think
Perception,
Dominic
good.
told me about something where people were in a cave, right? Or
It was, they had a room. They took groups of people. They took away all sense of time. No, they couldn't tell any time, and they didn't take like a day or night cycle there either. They had to decide for themselves what time it was. And progressively, everybody's internal clock was off by about 5 to 15 minutes every day, a little worse.
Okay, let me tell you a nice story about that. We do have an internal clock because our system needs that. Okay, what is our internal clock? How much is our internal clock?
Our circadian rhythm, I want to say 23 hours or so, something like that. Just shy of the actual number of the day that we.
Yeah. Isn't it interesting that our circadian rhythm is actually a little shorter than the actual day?
Yeah.
why is that?
Okay, what if I would tell you about 4 billion years ago, a planet size of Mars hit original Earth. They got molten together, and part of that was flung into space and then made the moon. The moon was so much closer to us, and the Earth was moving so much faster. At that time, Earth day was 6 hours. But at that time, life didn't exist. Since then, moon is going away from us 1 centimeter, 1/3 of an inch a year, and the Earth is slowing down. When the mammal came to exist and have a circadian rhythm, the Earth day was
23. Oh.
But then that is, our biology didn't really evolve more than that.
Why don't we like adapt to that? Why
Well,
does our circadian rhythm?
I'm alive.
But well, we see the sun, we don't need that. We have a circadian rhythm, we will readjust. It is like every day our biology goes and readjust our clock. to what the sun is and so on and so forth. So it doesn't need that. The evolution is extremely lazy. It does as much as it has to do to get you by, then stops there, and there's no more advantage, and there is no more advantage. Now, having said that, yes, you put them in a cave. My question was, how do you know what time it is? No sun, no clock, you rely on your circadian rhythm, right? You count, that's like no different. Like you say, 1 Mississippi, 2 Mississippi, you just keep counting the Mississippis and so on and so forth. But that is a process inside of you. That's still a process inside of you. But how do you know time is as well passing? What do you know when there is no external things? If there is no sun or moon or something else, you are in the middle of the space. There is no up and down. There is no sun. There is nothing turning and so on. Time become more or less meaningless.
Right.
But time still exists in a way that the philosophers have struggled to understand for millennia. What is time? What is actually going on? Is it a rigid concept like Newton thought time is a rigid continuous thing that is passing at regular intervals and so on. And first, about 120 years ago with Einstein, we understood that time is not a constant thing, is not even spaces. Space can contract and space-time continuum. And that is where it comes that the only thing that we know is constant in our universe is the speed of light, but not even speed of light, the speed of light in vacuum. That is the only constant that exists in our universe, and everything else is practically a stretch of that. Now, let me just give you an example that I think maybe it really brings out there the concept you want to talk about. Are we dead? Are we existing? Do we have an existence right now? Or is the whole history of humanity is already done and we are just an illusion that, that I feel your finger or I'm sitting here? Now, there is a concept called light cone in physics, meaning that there was a Big Bang and the information and the light start expanding at the speed of light, and the space got bigger and bigger, but then there are places in this light cone from the Big Bang to today that no matter what, light cannot reach you. There is no causality possible anymore. I know this is a lot of mumbo jumbo for lots of people, but this really works. And there is something we call a loaf, existent space-time loaf, like a loaf of bread. Imagine you have a loaf of bread and you can cut it like this straight down. Imagine this is a loaf of bread and we can cut it this way, or we can cut it this way, or we can cut it this way. Okay, now imagine everything starts from here. It is like a cone, space-time, light causality cone. And I'm here and you're here. Your now is my now. But I'm here, somebody's on the other side of the universe. I'm here, he's there, but until the time of that person reaches me, we are 1 billion years later. So what you are observing from him is 1 billion later for you, and vice versa. Your light starts going. If he looks at you with a telescope, by the time your light goes there, he's looking at the 1 billion years before.
Sort of like how there's some of the stars in the sky are already dead. They're still there.
But still, you would think that there is a now for you and there is a now for that person in this. If you cut that universe like a loaf of bread like that, it becomes crazy. If that person starts walking away from you, his now and your now, if you calculate that, are 300,000 year different just by walking away from you.
Mhm.
Or if he comes to you, he's now become like 300,000 years your future. If he walks away from you, you're now become 300,000 years past from you. Just by that speed, if you're far apart, you see, the concept of time completely, the way we understanding collapses, okay? It becomes almost ridiculously meaningless. And then we come to the concept of what does that really mean now? What does that mean, time? And then in that concept, then that makes sense that we are all dead and we are all alive at the same time. But then when we, in a moment, we get that, observe ourselves, in that moment, this possibility collapse. So right now, we're alive.
Mhm.
So I think that is but you had some other interesting concept as well. I want you to talk about what other conversation did you have with your friend about that?
So actually, I think the card analogy is going to work pretty well there, because the idea is that eventually the entropy in the universe is going to reach a point where we stop expanding and we have just a system of complete disorder.
Do you know what it's called?
I don't.
Big chill. It's called
yes,
big
yes,
chill.
yes, the big chill. And now there are some people that posit that after the big chill, because we don't really know enough of what's going to happen at that point, but they posit that.
Do you want to explain what big chill is actually?
Yeah. So essentially we have the Big Bang, that's the expansion of the universe, and we have this negative space, and it's getting to get to a point where it slows down and eventually just stops. And now it's called the big chill because at that point, the energy we'll have in the universe is very low. It's everything will be freezing, everything will be frozen, because energy will spread out to the point where atoms are starting off apart, that they're not colliding each other, which is what generates heat and energy. And so everything will be essentially colder than ice, colder than you can imagine. Now, the idea there is, though, there is still going to be some residual energy left that they will continue to just sort of move around a little bit. But given that after the big chill, if there is no big shrink where everything comes back into itself, because some people think the Big Bang is like the snapping of a rubber band and it goes out and it comes back in, that sort of thing. But if it doesn't and it stays out there, then we have infinity after that point, because everything will just exist forever like that.
So very nice the depiction of that thing. Imagine the lowest energy level in the universe is the surface of this table. Like this couldn't fall further, but if it's high, it can fall. Imagine now we have a deck of cards here, and it all falls down at the lowest level on the table. Now, sometime in very long past, like 13.7 billion years ago, based on our measurement, the whole universe was a point. The density of matter and the energy was infinite. And then space started expanding. Like, imagine that, you have like a gas, thermodynamic. That is what the thermodynamic is. That if you have a lots of compressed air and they expand, they become cooler, they need more volume, more space, but they become cooler. Universe was like that, expanded and got cooler. The temperature was infinite. When we reached the temperature at like $5,000, or even lower, then at that point, the universe was so hot that light couldn't travel long. That is why when we look back long in time, we still see that. We call it the infrared background radiation. There is a wall we cannot look beyond, because at that point back in time, the temperature of the universe was 3,000 Kelvin or more, so light couldn't even travel. We cannot ever look beyond that. But then the universe cooled down and down and down and down. What is the average temperature of the universe right now? 3 Kelvin, which is 3 Kelvin, which is about, right? The 3, there's, we have to do centigrade because Fahrenheit is a catastrophe and so on. But the 0 degrees Celsius is when water freezes. 100 degrees Celsius is water goes to steam, boils. Now, 273 degree minus Celsius is Kelvin,
Mhm.
and the average temperature of the universe is just 3 degrees above that.
Mhm.
But that's not the coldest temperature we have achieved. The coldest temperature we have achieved is in a lab somewhere in the United States, where we achieved at 0.000 multiple zero to Kelvin with some helium atom.
Mhm.
And when you are in that temperature, magical thing happen. Okay.
What?
We get to that in a second. Okay, so why am I talking about that? The concept of the Big Bang is that infinite density become colder and colder, and eventually everything becomes super cold. Even universe becomes dark, stars die, even they fall apart. And the last remnant of the universe will be some black holes. And then only thing that the way we know there is energy, anything out there, is when the energy goes from one place to another. When there is a gradient, there's more energy. So this is up here, and this is down there. This cannot go lower, but this can. So when I fall this, you hear it, you see it. There's the energy transfer. Eventually, everything will be at the same level of energy, and there will be no energy transfer whatsoever. That is the so-called big chill. The theory you're referring to is a philosophy, a theory. We have no proof of that maybe that level of the energy that universe achieve is just one level. Maybe below this table, there's a floor, then the whole thing can start again, and then the entropy again is higher, and then falls down. And when that happens, a new era starts again, and that is infinitely goes on and on and on and on. And there are some calculation that say that might be the case, and the universe might be eternal. There's no beginning, no end. But this is not the same cycle that with the rubber band you go in and contract, because we defeated that theory already. Universe is not slowing down. As a matter of fact, universe speeding up. That expansion of the universe, the cooling of the universe is not slowing down. It's actually speeding up.
Is it like an acceleration?
It's acceleration, yeah. That the amount of because we didn't understand it, we created the idea of dark energy, dark matter, and so on. The dark energy is actually 95% of the universe is the dark energy. Only everything you see in the universe is just 5% of what exists out there. But more or less, we know now universe is not contracting. So there's no rubber band. We are not coming back together. But maybe there's another level of energy that when the big chill comes, then it can fall off. It is like you fall from one steps to another, but there's another one down, another one down, another one down, and that can repeat itself. So there is hope for the universe. Okay. Now, by the way, the big chill. What is now? The age of the universe is calculated to 13.7 billion. When is the big chill is going to happen?
I think it's in the trillions.
Calendar.
I only think it's in the trillions. I'm not certain.
It's a multiple Google years.
Oh goodness.
Do you know what Google year is?
Its exponent is even higher. The trillions.
It's the 10 exponent 100. One with 100 zero in front of it, that many years or more actually for a big chill. So you guys just have to still pay your taxes. Go buy grocery, make dinner.
Yeah. Keep your plans for the weekend.
Keep the plans.
Don't burn any bridges.
Do not burn any bridges.
Yes.
Because big chill is not going to happen anytime soon.
And just because it's Google years doesn't mean to go buy Google stock. Okay, they're
Right.
separate things.
Yes, thank
No,
you.
as a matter of fact, that Google I'm talking about is actually Google, GOGGOL. And Google, they chose their name because of that, of mathematical concept.
It's a circle.
Yeah,
All comes back around.
No, they knew what Google is, and they choose the name because of that.
Yeah.
And
Because of like how many search results you can get. basically.
exactly. So
Well, when I chose this, or when I chose out of Dominic's topics, I guess I kind of more perceived it as like if the way I was viewing the conversation would be, are we alive? Not are we dead? So that will be another topic we can do is how do you know that you're alive?
No, do you observe yourself? This is an old philosophical question. I think so. I am.
What about when you're dreaming?
Well,
You
if you don't,
observe
if you're
yourself
not,
when you're dreaming.
well, if you're dead, you won't dream either. So
right.
dream thinking, that is a proof this is a philosophical concept. This is a proof that you exist because you think, or you can expand it because you dream, because you
because you experience.
You have the experience, and that is a proof of your existence. Now, you exist. That it's become really interesting now. I know I exist because I think I have my perception inside of me. But how do I know you exist? Maybe you're all in my imagination.
He's on us.
That used to, when I was younger, that used to be like something I thought about every day is how do I know everyone around me is alive and they're not just like a figment of my imagination, or like if we're all living in some type of game or something. These are things that used to really keep me up at night.
Knowing you, I think if I was fiction of your imagination,
you'd be so much
chill. I would be so much more chill.
Well, thank you guys for watching. Join us in 5 minutes and we're going to talk about regenerative medicine.
Okay.
This is essence of life, even though do you really think nothing that you talked about was science related?
Not
Dominic, please.
Oh, okay.
Tell me that was not science.
And I like you, but he writes the paycheck.
See, everything we talked about, it cannot be empirically proven in any ways. So that makes it a sense of, there were lots of scientific facts that we recited.
It was all scientific facts reciting. This was essence of life. Are we dead? Thank you guys. And I'm Amanda Armagast.
Dominic Moore.
And I'm Dr. Abbasi for